The type of function we're talking about now is a non-hyperbolic rational function, and these are going to have variables in the numerator and denominator. The first type we studied only had variables in the denominator, so these will have both. These graphs will still have a vertical asymptote at any value that gives you 0 in the denominator. So how are we going to find vertical asymptotes? Well, the easiest way to find a vertical asymptote is just to set the denominator equal to 0. And any values that you get will be a vertical asymptote. The domain of the function will be all real numbers except any x values that give you vertical asymptotes. So let's say that we had found our denominator was x plus 7. Well, we set x plus 7 equal to 0, and that gives you a vertical asymptote at x equals -7. So then our domain would be -infinity to -7, and then -7 to infinity. So to find our domain, we just go from -infinity and then skip over the vertical asymptotes. Finding zeros will also give us useful points. To find zeros, which are also called x-intercepts, which are also called roots, what we're going to do is set the numerator equal to 0 and solve. After we do all those steps, we can use an XY chart to help locate other points on the graph, and we'll show you how to use the table feature of your graphing calculator to help you do that. Horizontal asymptotes. Horizontal asymptotes are found by comparing the degrees of the numerator and the denominator. If the degree of the numerator is less than the degree of the denominator, then you have a horizontal asymptote at y equals 0. If the degree of the numerator is equal to the degree of the denominator, you have a horizontal asymptote at y equals, and we're going to need to compare the coefficient of the numerator to the coefficient of the denominator. So it's going to be y equals a fraction made out of the leading coefficient of the numerator over the leading coefficient of the denominator. And if the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. And that's as far as we're really going to go with those this year, but you may want to take note that there is an oblique or slant asymptote, and you'll get into that in later math classes. And just a side note, it is possible for a graph to cross a horizontal asymptote. A graph will never cross a vertical asymptote, but it's possible for them to cross horizontal asymptotes. So let's practice identifying asymptotes, vertical and horizontal. Vertical asymptotes, remember we find those by setting the denominator equal to 0, so x squared minus x equals 0, and then I can factor out an x, so x times x minus 1 equals 0, and that gives me x equals 0, x minus 1 equals 0. So this graph has two vertical asymptotes, one at x equals 0 and one at x equals 1. Horizontal asymptote, I'm going to compare the degree of the numerator. So the degree of the numerator is 1, the degree of the denominator is 2, and since the degree of the numerator is less than the degree of the denominator, I will have a horizontal asymptote at y equals 0. Let's see, g of x. To find the vertical asymptotes, set the denominator equal to 0. This factors by difference of squares to x plus 5 times x minus 5. So I'm going to have two vertical asymptotes, one at x equals -5 and one at x equals 5. For the horizontal asymptotes, we want to compare the degree of the numerator. Degree of the numerator is 2. Degree of the denominator is 2 also. And since those are equal, the degree of the numerator is equal to the degree of the denominator, we need a horizontal asymptote at y equals, we need the leading coefficient of the numerator, that's 2, over leading coefficient of the denominator, which is 1, so y equals 2. H of x, set the denominator equal to 0, we get one vertical asymptote at x equals -1. Comparing the degrees, the degree of the numerator is 2, which is greater than the degree of the denominator. So by our chart, when the degree of the numerator is greater, there is no horizontal asymptote. F of x equals 3x plus x. Set the denominator equal to 0. We get a vertical asymptote at x equals -4. And then comparing the degrees, the numerator has a degree of 1. The denominator also has a degree of 1, so they are equal, which means I need the ratio of leading coefficients. And if I simplify this, I'll get 4x over x plus 4. So my horizontal asymptote will be y equals 4 over 1, so y equals 4. My last one, set the denominator equal to 0 to get the vertical asymptote. This will factor into x minus 3 times x plus 2. So I get x minus 3 equals 0, which gives me an asymptote at x equals 3. X plus 2 equals 0, which gives me an asymptote at x equals -2. Horizontal, the degree of the numerator is 1. Degree of the denominator is 2, which is less. So I'll have a horizontal asymptote at y equals 0. Well, let's go ahead and put this all together and take on an entire problem. So I want to start with my vertical asymptote. So I do that by setting the denominator equal to 0, which gives me a vertical asymptote at x equals -1. So I'm going to graph that in there. Vertical line, x equals -1. The domain, remember for domain, I just skip over any vertical asymptotes I have. So I go -infinity to -1, skip over -1, and go back from -1 to infinity. Horizontal asymptote. The degree of the numerator is 2, degree of the denominator is 1, and that means the numerator is bigger than the denominator, so I will have no horizontal asymptote. For x-intercepts, when I have a non-hyperbolic rational function, to find x-intercepts, I set the numerator equal to 0. This will factor into x plus 5 times x minus 1. So my x-intercepts, I set each factor equal, x minus 1 equals 0. That gives me an x-intercept at -5, 0, and at 1, 0. So I can put those on there. 1, 2, 3, 4, 5. And then I want to make an XY chart using my graphing calculator. So let me grab that real quick. If you don't have a graphing calculator, you can always calculate these by hand. But I'm going to use my graphing calculator. So what I'll do is I'll go into the y equals screen, and I'm going to type my function. You want to make sure that you get your numerator in parentheses, so x squared plus 4x minus 5, and then divided by, put the denominator in parentheses, x plus 1. Before you go to the table, make sure, go in your table set menu, so second table set, make sure that your independent is set to ask and your dependent is set to auto. Then when you go to the table, even though I have values in there, I can clear all of those out. And then I'll be able to type in x values. So I'm going to start with x equals 0. If I put in 0, I get out -5, so that's an ordered pair. If I put in 2, I get 2.3 to 2.3. Let's see what happens if I put in 5. I get 6.7. So 1, 2, 3, 4, 5. 1, 2, 3, 6.7. I'm getting a pretty good picture of what's going on this side of my graph. I can go ahead and connect those dots. Now I know, oops, we'll just pretend that looked good. I know that my graph on this side of the asymptote is not going to connect with this side. So I picked some values on this side. Now I'm going to go over here and pick some values to the left of my vertical asymptote. So let's choose -2. At -2, I get 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. At -3, I get 4. At -4, 1.7. If I put -5 in there, I'll get 0 out, which is good because that's where my x-intercept is. How about -6? -1.4, and just for good measure, -7, -2.7. And then I want to connect those dots, making sure that I don't cross my vertical asymptote, but I do connect my dots with a nice smooth line. So that's my non-hyperbolic rational function. Let's look at this next one. We're going to follow the same steps. We'll find the vertical asymptote by setting the denominator equal to 0. This factors x plus 1, x minus 1. So I have two vertical asymptotes, x equals -1 and x equals 1. The domain is going to go from -infinity to infinity, but we have to skip over the vertical asymptotes. So we'll go from -infinity to -1, skip over -1 and go to 1, skip over 1 and go to infinity. Horizontal asymptotes I get by looking at the degree of the numerator and denominator. The degree of the numerator is 1, degree of the denominator is 2. The numerator is less than the denominator, which when we refer to our chart, that tells us we have a horizontal asymptote at y equals 0. So we'll go ahead and put that in at y equals 0. And x-intercepts, remember we get those from setting the numerator equal to 0. So x minus 2 equals 0 gives me an x-intercept at 2, 0. Now that touches the horizontal asymptote, but that's okay, because remember I told you that graphs can cross those horizontal asymptotes. Next, I have an XY chart. Now what you'll see on this one is that I gave 3 different XY charts here. That's because when I have 3 different sections, when my domain is separated into 3 different sections, I usually will make an XY chart for each section because they're not connected to each other. So that's just one of my habits. So I'll go ahead and enter this in. I have x minus 2 in parentheses divided by x squared minus 1 also in parentheses. And I'll go to the table. So I'll work on this section first. So I'll maybe pick -2, -1.3, -2, -1.3, maybe -3, -0.6, -4, I get -0.4. So it looks like it's just getting closer and closer to that horizontal asymptote. Let's see what happens at like -7. At -7, it's at -0.2. So that's just getting closer and closer and closer. Let's see what happens near this x asymptote. So maybe at -1.5. Negative 1.5 gives me negative 2.8. So negative 1.5, almost negative 3. So I've got a nice picture of what's going on here. Remember that a graph will not cross a vertical asymptote. What happens near a vertical asymptote is that a graph will either zoom up, so zooms up along the axis, along the asymptote, or zoomed down along the vertical asymptote. So what I can see here is that my graph was starting to zoom down, so I just went ahead and sketched that in without picking a bunch of other values. Then we'll pick some values in between negative 1 and 1 to go in this second chart. So maybe let's pick 0. 0, 2 is 1 point. Let's pick negative 0.5. Negative 0.5 is 3.3. Let's pick positive 0.5. I can't see that. 0.5 is 2. Let's pick 0.9 and see what's going on. At 0.9, we're at 5.8. Let's see what's happening between 0 and 0.5. So maybe 0.25. 0.25, we're at 1.9. So it's a little bit down. And maybe at negative 0.9, which is almost at the other asymptote, that's at 15.3. So it's zooming up. So I can sketch in here, knowing that my 3 branches will not be attached to each other. They're 3 separate pieces. So then I need to pick some points over on this side. I want to pick one between my x-intercept and my asymptote to see if my graph is zooming up or zooming down. So if I choose 1.5, that gives me a value of negative 0.4. So that indicates to me that the graph, when it gets close to this asymptote, is going to be zooming down. So let's pick maybe 3. At 3, we're at 0.125. Let's see what's happening at 7. We're at 0.1. So it's kind of hanging out near this asymptote. If I pick something really close, like let's pick 1.1. At 1.1, the graph is at negative 4.3. So that just confirms that it's close there. So we can sketch this other branch of the graph. So now we have 3 branches to this rational function.